Hey everyone, it's been a bit since we went through the first part, but I'm continuing on with the grind rail by adding a couple new features. We've got collision detection into ragdoll, we've got reversible directions, jumping between rails, a few fixes to the old project, looping railings, and a bit more. So check the description for links to the free blueprints so you can follow along with this tutorial, and check out the previous tutorials on splines and part 1 to see how we got here. Everything I have open now is a free download from the Ko-fi link in the description. There's also links to the previous tutorials on making the spline that we use as the grind rail, and I would recommend checking those out if you haven't already. But a quick overview of some of the changes that have been made over the last year. I've added a set enable collision to disable the collision to the spline line when we jump off of it. There was an issue where initiating a jump in the middle of the spline may cause the capsule component to become locked into the spline, and about half a second after we jump off, it gives enough time for us to adjust our offset so that we turn it back on, and that eliminates any issues you may be having with the character getting stuck. I've also moved some things around, like the get relative locations being put before we start moving on the grind rail, whereas before that was on the auto update distance. I've also removed a loop that used to be here and replaced a function with a get distance along spline at location. Other than that, everything is exactly as we left off in the last video, just a bit more cleaned up. So for our new features, we're going to start off by having a reversible direction. So in our spline blueprint, we're going to add a new variable. We'll just call it reverse direction. And we'll set that to be instance editable and expose it on spawn. And back in our grind rail, on our grind start event, when we go and move, we add a grind speed value, which I had set at 10. When we reverse this, we're going to just simply drag in our spline, because this is going to be referencing whatever spline we're currently moving on. We can get reverse direction. And then we can select a float. Just cut the grind speed, and we're going to multiply it by our selected float. So we're going to pick A to reverse the direction by multiplying -1. Otherwise, we're just going to choose 1 to add a grind speed normally. So now if we were to select the spline and we select reverse direction, we're going to go backwards. Now we still need to be able to turn our character around because our trace is facing the direction of the spline. Which means we need to reverse the rotation on our set actor rotation down the update distance. So we're just going to delete the pin between our return value from our find rotation closest to world location. And instead we're going to select a rotator, with the return value being our new actor rotation. Get our spline line. We'll get reverse direction. Now return value, plug into B. Otherwise for A, we're going to break the rotator into axes. And we need to invert the X and Y vector. So we're just going to multiply by -1 for each of these. Then we're going to make rotation from axis. Connect our pins and have that be A. Now when we jump on the spline, moves our character in the right direction. Next, we're going to be making a loop track. So we're just going to take a spline and wrap it around. Now, there is a function that is already built into this called a closed loop, which you can get on the spline. When you click it, it does create this arrow. Unfortunately, if we go into our splines with the way that this is done, theoretically, if we just copied everything up until the start and end function, put it on our completed, we can get one more starting from our index that we last set, going all the way to the first index at 0. And then that should have a mesh that connects our endpoint to our start point, however, it gets deformed. So instead of doing all of that, we're going to do it the lazy way. We're going to physically drag out the points to make a circle. And just like every other object, if you hold down Alt and drag when you're on a spline point, it will just create a new one for you. And if you click on the spline, you do have these selected spline points. So if you click on or just one spline, you could toggle which spline point you're on by just clicking the buttons that show up here to select or move which spline point you're connecting to. And then once you have a ring, highlight them and move them 20 degrees inwards where the arrows face. That will have our character rotate in that direction to give an inward bend to make it look more realistic. So when we hop on, this will only go up to the edge and it won't go any further. To change that, we're going to go back to our move event. And after our distance along spline, we're going to duplicate that. Then we're going to collapse it into a node to save some space. And we'll just call the node loop. And we can drag the execute pins into it and open that up. And the operation is pretty simple. When we get to the max distance of the spline, we're going to set it to 0, and if we're going in reverse, if we get to 0, we're going to set it to be the max distance along the spline. So we'll put a branch right before our distance along spline, and connect that to our distance along spline and output. We're going to take our spline line and get the actual spline. Then we're going to get the spline length. We're going to check to see if our distance along the spline is greater than or equal to our max length. Then we'll just copy our distance along the spline and check to see if it's less than or equal to 0. And we're going to get our spline line again, get the reverse direction. Then we're going to right click and get select. And we could just put the reverse direction into where it says index. And so if we're going in the reverse direction, we're checking to see if our distance along the spline has reached 0. So that will be in true. Otherwise, we'll connect our top boolean to false, and we'll connect that to the branch. Otherwise, if we're not at the endpoints of either end of the spline, we're just going to ignore the distance along the spline, and we're going to bypass it entirely. Then we can copy our spline line in reverse direction and get another select float. So when this is true, we're going to set the return value as our distance along spline. If we're not reversing direction, then we can leave B as 0 because we're going to be starting the loop again. Otherwise, we're going to have to take the spline and just get the spline length. And set that to be A. So that's done when we jump on it, go around, and we keep going around. If it gives a stutter like that, it's because your spline points are not directly overlapping one another. So the easiest way of doing that is clicking onto the spline. Click the spline point, you'll see the input key. So 7 is going to be our last one. We have the location of 540, 250, 0. If we go to the first spline, you can click the select first spline point and select last spline point to compare these values. Just looks like this did not get rotated correctly. And now it seems to be going smoothly. And if we uncheck the reverse direction, it successfully goes in a loop. So next we're going to have a custom event set up for us to be able to have collision detection. So when we're grinding on a rail and we hit an object, we're just going to ragdoll the character mesh and try to keep the capsule aligned with the mesh while simulating physics. So right at the end of our event to update the distance, we could just call this event collision check. We're going to get a reference to our character, and we're going to get the capsule component. Then we're going to get our actor's location. And we're going to get a capsule trace. Since our actual capsule is going to be inside of the spline, we want to have this trace around the mesh of our actor. So we're just going to add to our actor location, and then add the offset for our actor mesh. You can also add the relative location of your character's mesh. I'm just doing it manually for demonstration purposes. This location is going to be the start and end, and we'll have this match the capsule radius and capsule half height. And we want to make sure that we're not going to be clipping with the spline, so we can drag out our spline line and add it to our actors to ignore. and that will automatically make an array, and you can add anything else that you want to have to ignore this collision, because we want to keep the trace channel on visibility. If we do end up hitting something, we're going to end our trace timer. We're going to leave some space because we're going to add another event right here when we get to jumping from rail to rail. We're going to set on spline to be false. Then we'll take our character, and we'll get the capsule component. We want to have the collision disabled, so we'll set collision enabled. And keep it to no collision. Then we'll get the vectors mesh. We're going to set all bodies below simulate physics. So we're going to take our root bone, which is going to be the pelvis, and we're just going to make a literal name. That will be pelvis, all lowercase. And we'll do a new simulate, and we'll include self. Then we'll set yet another timer by event. Add a custom event, and this will be to update our capsule location. Set it to be looping. We can copy our character and capsule component. And we'll set the world location. Copy our mesh. We'll get the socket location, specifically of the pelvis bone, and set that to be our new location. So now I'm going to just remove our loop. Move that, and I'm going to add a new spline. Let's place an object in the way. So now when we hit this at the end of our update distance, we have a check. So now we'll automatically rail jump when we get to the end of the spline, but if we intersect with something, we're going to call our collision check. Okay. And if that happens, it's because in our third-person character, we want to make sure that our character mesh is configured correctly. So we can go to the collision settings. And we want to change our collision enabled from query to collision enabled. Instead of just updating a timer and setting all simulated physics, you can play an animation for a stagger and just call the end of the trace, as we did right here, and that will knock the character off. We're not going to go much further than that. How far you want to integrate that into your project is up to you. So now we're going to move from rail to rail, and the way that we're going to set that up is by using our action input for our movement. In short, we're going to get a box trace. And that trace is going to go to the left and right of our character depending on what action value we input. So we can right click on the action value in our move and split the pin. And when we have the trace highlight another spline, we're going to set that to be a new variable for a spline to us to jump to. And when we no longer have a spline that's being highlighted by a box trace, either because we're doing a trace and not colliding with anything, or we don't have an action value input, we're going to clear it. So we get a branch connected to our triggered. And we're only going to want to do this if we're on the spline. For our orientation, we're going to take the character and match it with our character's rotation. And we only really care about our action value X since it's going to be our left and right. So we're going to get a multiply. Then we're going to copy and paste and connect the action value below. We don't want this to start directly on our character, so we're going to start it, we'll say 200 units away, and we're going to have it end 300 units away. We're going to have to get the actor's location and the actor's right vector, and multiply the right vectors by our multipliers here. So we'll get the character, get actor location, get actor right vector, then we can duplicate that to below. We'll add from our actor location 200 multiplied by our right vector. And that's going to be our start. And we're essentially copying what we did and connect 300 to our multiplied, making sure that this is a float. And that will be our end. So we'll enable the debug for the duration. And also for our half size, we can set this to be something like 60, 60, 200 to make a big enough box to be able to see. So now when we grind, we hold down left and right. Those are the size that we're going to be working with. We'll just put a stop here so we can see it. So we'll be able to jump up rather high onto a new rail or low. So assuming that we do hit another object, we want to make sure that we're only going to be tracing the rail trace channel. We can break the out hit. And we want to save a reference to two variables. The first is the hit actor. So that'll be a new actor variable, and we'll call it next to spline. We'll have to cast to make this new spline actor referenced as BP splines. But we'll set that to be true. Then we're going to duplicate it and leave it as a null reference as false. So when we don't hit anything, that will clear our spline. And we're also going to want to keep the impact point for where we want to transition to on that spline for when we jump. We'll just call that new spline impact. And then off of completed, we're going to copy our branch So then when we take our finger off of our whatever left and right input is going to be, take our next spline, and clear the value. So now that we have our next spline, we're going to move from our current spline to our next one. So we're going to go up to our jump logic, and we're going to disconnect the rail jump. We're going to create a new custom event, and I'm just going to call it rail to rail. Not the most clever name, but we're going to split this into two different options. We're going to take our next spline and convert it to a validated get. If we don't have a next spline, we're just going to do our rail jump as normal, which is just jumping off the rail. However, if we do, then we're going to play a montage. So we'll get rid of character, get the mesh. And we don't have any montages, so I'm just going to open up our jump animation and convert that to a montage really quick. And set that to be our montage. We're not going to do much with the control here, we're just going to continue past this. We're going to set our on spline to be false. And we're going to end our trace. We also want to stop moving as well on our spline, so we're going to end the spline movement timer. And at this point, we need to move on to the new spline. So we're going to take our next spline, and we're going to cast it to BP_splines, and then set our splines to be our spline line. We also want to set a location to move to on the next spline, so we're going to add a new variable that is going to be a vector. And this is going to be our new spline location. And so we're going to drag it out from our VP splines and then get our spline. And we're going to get distance along spline at location. The new in location is going to be the new spline impact point that we hit with our trace. We'll convert the coordinate space to world. And if we leave it as this and just set this as a new vector without adding any distance to it, we're going to be traveling, it's going to stop, it's going to switch over to the new spline, and then it's going to continue the trace when we get back onto the spline, so it's not going to keep momentum. To simulate that, we're going to add a value here, and we'll just say 500. Then we'll take our spline again, and we'll get the location at distance along spline. And connect the output to the distance, and change that to world space, and connect it to our spline location. Going to collapse this into a node to save space. We're going to call it move to spline. Then we want to make sure that our next spline is cleared after we set the cast, so we don't have any variables that are kept over. And we're going to transition from one point to the other using a timer, just because this is built in a component. We can't use timelines, which is why we're using an excessive amount of timers. Got a custom event and call transition to rail. And we'll need to promote that to a variable to cancel it later. We'll just call it rail transition timer. Loop it, have it on a 0.01 second loop. While we're moving off of the spline, we still want to call a collision check. That way, if we're moving and we hit an object, it'll ragdoll the character. Then we'll need to take our character and set the actor's location. To find the location, we're going to use a VInterp to constant. Starting, of course, with the character's location. And we'll want to get our new spline location as the endpoint. We're going to break this vector, and we'll also break the vector of our target on the constant. Our x and y are going to be the same, but we want to have sort of a parabolic jump to this. So we're going to set a half height. So then when it gets to the half height, leading up to it, we're going up. And then after the halfway point, we're going down. And then after we get to the location, we'll have some logic here to stop our timer when we reach close enough to the destination. But for the delta time and the interp speed, we'll set those both to 3. And for our z value, we're going to need to add. We'll need to get the distance between where our character is and our spline location vector, so we'll just copy our actor's location, copy the spline location, and subtract both. Then we'll get the vector length. We're only really going to care about the x and y value, though. So we're going to get a less than. And we're going to select a float. For A, we'll set that as 200, and B, we'll set as 0. So when this is A, we're going to make a variable that's going to be our jump half height. So we'll right-click on that and promote it. Jump half height. And the way that we'll calculate this, we're going to use the same logic, however, we need to call it before we start interpreting. That way it's a constant, so we're going to get this right before we cast it. Setting our jump half height. We're going to take our vector length and then divide it by 2. Click on that, collapse to a node, and I'll call it calc jump apex. Then we'll get a branch. We're going to check to see is our new spline location equal to the return value of our VInterp. And we'll give it a tolerance of 0.1. If it is, we're going to stop our transition, which we're going to make a custom event. Stop transition timer. Just going to cut that and put that with the rest of our timers. And now that we go onto the new spline, we need to update its distance down the spline. So we're going to find spline distance at overlap. Using our spline line. And the new spline location. Then at this point we're going to be on the spline, so we'll check that as true. And then we're going to start the grind. So we'll take the spline, duplicate it. We actually need to take our distance along spline and set that after our function. There we go. Now we have a seamless transition. Now we need to worry about the rotation. So we'll take our character and we'll set the actor's rotation. This will be good if you wanted to jump on a rail where the character is angled at the side. Otherwise, it's going to jump off keeping that same angle and then snap to whatever the angle of the mesh is going to be given the up vector of the new spline. So we're going to rInterrupt to constant. Just going to build this up here where we have some space. Delta time and interrupt speed can both be 1. Current rotation, as always, is going to be the character's current rotation. And luckily, the target rotation we already kind of have done for us. It's going to be the select vector with the reverse direction that we made, as well as the rotation closest to world location and our next location on spline. And we'll name this event transition rotation. Then we'll just configure our spline, make sure to uncheck space meshes. That way it shows the up arrow so you can see more accurately where the spline points are. Set the rotation of the spline so then our character rotates sideways. When we jump, our character will transition back as normal, and because we didn't have anything that we hit, we could just use the rail jump to jump off as we would. Okay, and then we're going to move our obstacle up a bit and go back to our collision timer. We had left the collision check off with a space for us to end our transition. So we're going to call the stop transition timer when we do the collision check. Otherwise, when we start, we try to move. Otherwise, when we start, we try to move too late. It's going to give this shuddering because our character is still trying to move there. That way when we jump too late and we collide with something, gives a much more pleasant experience. Not for Manny, but for the player. Okay, and there's one last thing to fix, and that is all the way back in our move to spline right after we move to the new spline. Because we added 500 here, we don't have this set up to be a reversible direction. So we can do the same thing as before, where we get the spline line, we get the reverse direction, select a float, and we'll subtract 500, or we'll add 500. That way, either direction, we can move. However, when we get to this point, we're not considering that we could be close enough to the end of a rail, and so we'll jump past a location on the rail. So if I were to just shorten these, you see that it just started over. So to compensate for that, we're just going to put a branch and drag from an input here. We're going to put this after the cast to the spline line. And we're going to get a condition here. We're going to check to see if our selected float is greater than, or if it's less than. So if it's less than 0, we'll be going the reverse direction anyway, so we don't want to loop it. That's fine. Otherwise, we're going to get the spline, and we're going to get the length of the spline and compare that to our greater than check. So if it is not greater than the length of our spline or less than 0, we'll connect that through the execute, and then we'll go through the whole process of transitioning. Otherwise, we're going to jump off the rail by calling rail jump. So that's that. Lots of new things to add to the grind rail. Now, I'm going to start off by saying thank you to everyone who supported me on Patreon. I have now moved over to Ko-fi for privacy reasons, and sadly that tanked my support, but I kind of knew that it would. So I'm essentially starting from scratch, but I wanted to say thank you again to the pillars of the Patreon: Winterberry Shark, Francesco Pota, K Panic, and Shay Alexander, and to all the cool people who have supported me up to this point. If you want to throw some support my way, everything that I put up on Patreon is now on Ko-fi. There's also a few projects and animations that are now free, so you can check the description for the shop link. If you sign up as a member, you'll have access to everything I've done set up as an Actor Blueprint component. You'll also have links to super secret tutorials that dive deeper into topics that I cover on the public videos. But that's pretty much all that I've got, so thank you all for watching, and I hope you've been inspired.